Hey, there we go. Good morning, good afternoon, good evening, whatever time it might be where you are out there. Welcome back to the live stream. My name is Fritz, and today we're going to be writing a little bit of code, and this is C# with CSharpFritz. We write some code here. We have a little bit of a discussion. We talk, and we learn. We get into the beginnings of C#. And this is episode 10 of an ongoing series that we started way back in September. Learning about C#, getting into the basics, building our first code, and today we're going to start writing our first tests, building our first solution files, and working on projects together. Really looking forward to this. Let me say hello. Let's say hello to the folks here in the chat room. They're over here. Hello. Shy Sharp is here. Viral Flows Lithics. Good evening to you. Hello to you, Viral Flows, after a long time. Always great to have folks come back and tune in. These videos are archived. They're over on the YouTube channel. And of course, you can watch us live Mondays, 9 a.m. Eastern, 6 a.m. Pacific. And now with the time change, 1400 UTC. You can also find us over here. Coated Beard is here. Pro Bricks, Black Eye, Betancourse. Hello to you, Betancourse. Good morning. Good afternoon, Coated Beard. John Mazza is here. Hootenheimer. Good morning to you. So this is the first of this is going to be our first episode where we're going to step outside the browser. We're going to get into actually writing code on disk. And I'm going to focus on using Visual Studio Code today, but we're going to learn how to start using our tools, how to start putting together more than just a couple lines of C# code here and there. We're going to start to get a little bit more productive in writing code that compiles together, that we have to compile, evaluate, and take appropriate steps on our machines or on other folks' machines if we're doing some sort of remoting operation. But we're going to learn how to put those pieces together and start building our first solution. And we'll talk a little bit more about the project here in just a little bit. Let me get some music playing in the background here. This is Stream Beats by our friend Harris Heller. This is music that's licensed, it's free to listen to, free for folks to use. It's copyright free. Anybody can use it anywhere they'd like on Twitch, YouTube, all those places. And today we're going to be playing the Lo-Fi playlist. Bunch of really groovy music that's just great to listen to in the background. It's not going to interrupt us, but it's going to help to fill some of the quiet space so that we can talk and have some groovy music in the background there. So this first song is called Zen, and we'll provide a link in the YouTube description below to Harris Heller's Stream Beats, and you can listen to them while you're writing code, documentation, doing homework, whatever it might be that you're working on. So thank you so much, Harris. We appreciate you sharing your music. And we'll listen to it here in the background as we're writing some code together. Let me take a look here. Eeny, meeny, miny. Okay, we're good. So I've got a lot of notes for today. I've got a lot of things that we're going to be going through. And I wanted to do a bit of this live coding style. See where our discussions take us. And fill in the notes, fill in the content appropriately, because I'm doing a little bit of representing content from within the documentation. If we decide not to go too far down there, well, we'll pivot and go in a slightly different direction. And that's part of the benefit of watching the live stream while we're here together. Being able to ask questions and help drive the direction for this. You're already relaxed? Fantastic, John Mazza. Glad to hear it. So, let's head over to the code and take a look at our GitHub. Talk about what we're doing today, and I want to give you a little bit of a hint of the schedule ahead for November. So let's take a look over there. Let's head over to that. Gonna head over, making my way over to my desktop. Here we go, and there I am. This is our GitHub repository, C# with CSharpFritz. Let me turn on, I have a command here that we can execute in the channel that you can execute and see, get quick access to this repository. There's the link, and I'm going to turn on our commands over here that also give you access to the YouTube channel. Not access to it, but you'll be able to run a command and get a reference to it. Yes, we're going to tell lame dad jokes today as well. Yes, that's part of what we do, is tell lame dad jokes. Okay, maybe not always what we do, but it's kind of a thing, right? So let's I'm keeping an eye on things here. I want to make sure I have that running properly. Good. All right. So here in the GitHub repository, this is where everything happens around the show. All the things that we're doing, all the things that we're going to be talking about, issues, questions that folks raise. You can log them here in the Issues tab, and we'll address them. If you have questions about the content that's going on inside of the project, log them in the comments below if you're watching the YouTube video, or if you're here on Twitch, write them in the Twitch chat, and we'll get to those immediately, and you'll see the messages pop up over there on the side, the various questions that are asked during the live stream, and there'll be links to those below so you can go back to them later if you need to reference. So, typically, I tell you, we're going to click through the Launch Binder link and run our Jupyter notebooks. We're moving away from that because we're getting into full solutions, complete projects. And for this, we need to now level up our tools. We need to get outside the browser and actually work with text editors and tools that are going to help to compile, help to turn our source code into real applications. And you're going to see in our first episode that goes through that process, you're going to see how we configure and how we get that running today. I do want to show you in our projects list, this is where you'll see my thinking and planning around what's coming in the future sessions. We're focusing on unit testing today, and as I got into writing about the unit testing topic, I realized we need to talk about installing the .NET SDK. We need to talk about what a project is, namespaces, solutions. So we're going to be covering that topic today. Next week is .NET Conf. We have that coming up. And along with .NET Conf is the release of .NET 5. Huge release, new major version of all of the tools, all of the frameworks available for you as a .NET developer, as a C# developer, including C# 9. Now, I don't want to cover C# 9 until it's released. So what I want to cover on Monday next week, .NET Conf starts on Tuesday. On Monday, I think we should cover Entity Framework and talk about getting and interacting with data from an SQL database. And we'll particularly work with SQLite, but all of the things that we're going to be working with will also work with SQL Server, Postgres, MySQL, Oracle, DB2, choose your favorite SQL database. Entity Framework is a fantastic object relational mapper that sits in front of those databases and will help you write code to interact with them. Since we have .NET Conf Tuesday, Wednesday, Thursday next week, that's November 10, 11, and 12. I hope you tune in. We've got almost 70 sessions of amazing presenters and information about all the new things that are going on in .NET, including 24 hours straight of folks from the .NET community showing various community projects, various tips and tricks and techniques that they've found success with as they've been going through the preview versions and now the release candidate of .NET 5. So make sure you tune in for any part of that. Day one is 8 to 9 hours, including an attendee party that we call a code party at the end of the day. I hope you tune in. Day one is all Microsoft presenters teaching about all the cool new things that are happening, including C# 9. Day 2 is technically from 9 a.m. to about 5 p.m. Pacific time. That's noon for folks on the East Coast, and the 5 p.m. UTC time. Now, that's fine. It's technically that long, but at 5 p.m., we kind of flip the switch and we go into community mode, and for 24 hours straight around the globe, speakers from every continent except for Antarctica. I couldn't find an Arctic speaker this year. We have folks joining us. Every time zone is represented, and you'll be able to learn all kinds of great things about .NET in that 24-hour cycle. So there's my pitch about .NET Conf. But the Monday after .NET Conf, we're going to talk about C# 9 features and dial those into our learnings here on the stream. So next week, Entity Framework. The week after, C# 9. The week after that, we're going to start talking about user interface, and it sounds like we want to start building our first Blazor application. So we've had an issue out here that folks have been able to click into and vote on. It is down here, user interface frameworks. And I've asked folks to vote with a thumbs up on what they'd like to see. Oh, actually, it looks like ASP.NET Core just surged to the lead here. So you can click through to this issue, vote with an emote, thumbs up appropriately on which one of these frameworks you'd like to see us as our discuss and cover first. And it looks like we're going to talk about ASP.NET Core, and then Blazor, maybe WPF or Xamarin later. So looks like we're definitely getting into a web framework here, and that's what we will be learning about. There's a question here from Priyanka in the chat room. Let me put this up. Which version of Entity Framework will we be using? Even though it's just before .NET Conf and the full release of Entity Framework Core 5, I will be using Entity Framework Core, and I won't be going down into any 5 specific features, but I will be using version 5 just because it's here, the release candidate is done. At that time, it's going to be pretty well locked in. So I won't cover any of the Entity Framework 5 features, but we will be using Entity Framework Core 5. Hey Spotagus, welcome in. Black Eye with a follow-up question. Will I use any mapping tool like AutoMapper or similar? No. I don't want to get into anything, any of those tools. These are great tools. These are great libraries that'll help you with managing, interacting with your projects and moving things around. They have a place. I want to stay as simple as possible to show how to use some of these frameworks. I won't get into these as part of that. So they have their place, but I want to stay simple and focus on what you can accomplish with the frameworks. So that's what I have planned. That's what I have coming up in the next few weeks. I'm woefully behind on publishing a blog post about this series, about the GitHub repository, and how this all fits together. I also have a blog post that I've been writing about how I use Jupyter Notebooks as part of this. So a little bit of work that I have to publish, but coming soon. All right. So let's talk about getting started with .NET on the metal, on the actual physical machine that you're using. Now, this means you're going to need a laptop or a desktop. You can even work on a Chromebook, but you won't be able to work on a tablet or a phone directly. You'll have to remote into another system in order to participate and go through the samples, follow the code that we're going to be working on today. We're going to start building out a sessions folder here, and this is I'm calling this Season 01. This is Session 10. When we get into the user interface framework, I think we'll call that Season 2 of this, which lines up kind of nicely with the month of December. So this is Session 10. We're going to talk about projects, solutions, and unit testing. If you'd like to follow the actual document that I'm working with here, there's a link to the folder where the sample code is that I'm working with today. It's not quite complete sample code. It will be complete when we're done writing our code today. But you can follow along. You can scroll ahead if you'd like. I have a copy of this up on another screen over here so that I can see exactly what's going on and follow my notes as we're building and working together today. Oh, that's an interesting question. Is that Palamin? Is it Palamin or Palamin? Let me know. I want to make sure I pronounce your names correctly. Any chance of including a behind the scenes in the future? Well, there's a green screen behind me. What kind of information would you be interested in learning about? I'd be happy to. We did the errata show to catch up on some of the missed topics. Behind the scenes, I'd be happy to talk a little bit more about how these streams are produced, how some of the code is written. What would you be interested in? Let me know, chat room. Go ahead and sound off there. And if you're watching the recording, if there's any production information that you're interested in learning about, let me know in the comments below. I think this is a fine idea. We can definitely talk about that. Write up a blog post, include some video. Lithix is even going so far in the chat room to say some bloopers. I don't have bloopers. I'm just the way we expect this to be. I don't know. I haven't cut any content out of a stream, any of these streams, because they're just the way we planned them. Let me know. I can think about that, but yeah, what would you like to see? What would you like to learn about what would you like to learn about how this is produced? I'm happy to show how OBS works, how OBS, the Open Broadcaster software, that's what I use to assemble and produce the scenes that you see here. Happy to show a little bit of how the notebooks work, how they're put together, how my process works when I go through and write the streams and the script for what we're working on. So happy to share that information with you. Paladin Fox chimes in here with some love from Costa Rica. Well, thank you, Paladin Fox. I appreciate that. If folks want to sign off where they're from, let me know. Costa Rica, that's amazing. I'm on the East Coast of the United States. And you're going to see some of our streams this week slow down or not run here on the Visual Studio channel, so they don't conflict too much with the American election and some of the other things that may be happening. Black Guy's interested in some tools and gadgets to switch screens. Oh yeah, we can definitely talk about that. Northern Virginia is where the giggles is. All right, cool. Another East Coast of the States. That's fantastic. So let's start talking about how you can get a copy of .NET. Get started building and writing applications. We've been doing this, like I said, in notebooks, but let's actually get productive and get some tools on our system that we can work with. Jobin PA is in from Costa Rica. The Netherlands is Mufana Blue. Kyrgyzstan. Oh my goodness. The fan of 30 STM. Oh yes, we're going to get into unit testing. It's going to, we need to set up a little bit, but we're going to get into unit testing and talk about some practices and some practical ways that we can do that. Spain, we've got some folks watching from 19Revan88. Cool, very cool. All right. Wales is where Better Call Sean is from. See, look at this. Fantastic. And Lithix is dialed in from Perth, Australia. Oh my goodness. That's awfully late. The .NET Conf after party starts at 1 a.m. for you? No, it's in the morning, actually. St. Petersburg, Russia is for Lucky Ducky. Oh my goodness. Thank you. Wisconsin is where Mr. Demon Wolf is. Hello, hello. So let me show you where you can go to get your copy of .NET. So, real easy. Get.net. Literally, it looks like a cheesy domain name, but there it is there in the chat room. I'll copy and put this in a link in the YouTube description below, but get.dot.net. And it will take you to this site where you can choose whatever, based on whatever operating system you're on, you can choose to download and install either .NET Core, .NET Framework. This will be updated on November 10th when .NET 5 is released. November 10th, 2020. You might be watching this sometime in the future, and it might not look like this because this .NET release candidate for .NET 5 will be launched, and you'll be able to download it down here appropriately. Now, we're building apps. We're not just running applications. So you need to download... Well, you could download the .NET Core SDK for .NET Core 3.1, but I'm using .NET 5, so I'm going to download the release candidate. Now, for those of you that are watching this before this is released, whenever you see a release candidate from the .NET team, it typically includes what we call a Go Live license. That's assurance to you that you're going to receive support, that you can start working with this. The API, the contents of it aren't going to change significantly. There might be some minor changes, but they're not going to change significantly as it gets ready for the final release, the RTM. We used to call that going gold, the release to manufacturer. Now it's released to the web, really, because it's being published for folks to download. So you can download this SDK, and in order for you to maintain support, you got to install the latest versions of this as it becomes production ready, as we get to that RTM. That's not too hard to consider if you're building and testing and you want to try out the release candidate version. So whether it's .NET 5, .NET 6, other versions of .NET in the future, you'll have that same experience. And there's links to the support cycle. Should be a link down here to support. You can click through and learn more about the support cycle for it if that's something that you and your organization is concerned about. It's pronounced Parlamen. Okay, fantastic. So real easy to download and get this started depending on what operating system you're on. There's various installers, there's binaries that you can download and extract, place appropriately on your machine so that you can interact with that. For this machine that I'm working on, this is a Windows machine. I've already downloaded the installer for .NET 5, and I have it running on my command line. I'm using Windows Terminal, and it's already here waiting for me to interact with right here. Let me, yeah, that's fine. I can execute and interact with it. Once I have it installed, I can run .NET info, and it will tell me, well, here's the version of the SDK that I'm running, .NET --info. And it'll tell me, well, this is a Windows machine. This is the Windows version that I see. That's interesting. I thought I installed the 2040. No matter. The runtime ID, this is an x64 Windows 10. We'll learn more about runtime IDs later. And exactly where this is installed on my machine. There's other SDKs that are installed, including the 31403, so I can work with and do things with older, the current supported version of .NET for me right now, November 2nd, 2020, is 3.1403. But you can see I have other .NET runtimes installed, including 2.1, 3.1. I have two different minor versions of 3.1, and there's the 5.0 RC2. So this is the release candidate version that'll help me write ASP.NET Core applications. Those are web applications. If you want to publish a website, you typically build with ASP.NET Core. There's ways to do that using some other things with .NET, but out of the box, we use ASP.NET Core as our framework. Windows Desktop app. If you want to build Windows desktop applications, you would use the Windows Desktop app framework to build appropriately with, there's two different user interface frameworks there that you can use. One is called Windows Forms, and that's the typical Battleship gray, forms that you would click through and interact with. And there's also WPF, which is a more native graphic card friendly development environment that allows you to be a lot more flexible with how you build and write your applications. It uses a version of a markup framework, not HTML like we have for the web, but a markup framework called XAML, XAML, that we use in WPF to build those application user interfaces. We also use XAML with the Xamarin mobile framework that we use with .NET, with C#, so that we can structure and build user interfaces that'll work on iPhone and Android devices. So lots of different options that are available to you with .NET to build applications. I'm going to take a look here at the chat room. Okay. So, now that's great. I'm seeing, these are the different frameworks that came out of the box or are already installed on my machine, because I've been building and working with .NET Core with .NET for a very long time. I guess that makes me old. Yeah, that's the thing. But when we want to start building an application, we have templates that ship as part of this, that adhere and provide and work with these frameworks so that you can get started building an application. So I'm going to create a new folder here so that I can work, and I'm not using the exact project files that were created as part of the source here, and I'll go through and write this code along the way with you live on stream. So let's call this learn about projects. Okay, so I'll go into that folder, and I can run .NET new, and it will show me a huge list of all the different project templates that come out of the box with the .NET SDK, right? The .NET command line tool here, we call it the .NET SDK, the Software Development Kit, SDK. Now, it's just a command line tool. Everything kind of jumps out of this .NET tool for us to interact with and do different things with our code, whether it's generate some base template files so that we can start building a project, connecting those projects together with other projects, getting package references like you may have done with a node project, right? You have a package JSON file, and you do an npm I to install package references from the npm, the node package manager resource. Well, we can do that as well here in .NET. So we'll also build our applications, we'll test our applications, all using the .NET command line. And there's tons of great templates here. There's more templates that are available that have been built by the community that are available for you to download and install, or maybe you want a specific template that folks at your organization, at your place of work, should adhere to, that have some standards, some standard references. Maybe there's some logo, some various elements that are required, that you want to have in all of the projects that your organization has. You can build your own template and install it so that folks always have a common starting point to build their applications. Always possible to do that, and all of these tools are extensible. They're open source. You can find them on GitHub if you go to github.com/dotnet, and you'll find the entire repository of all of the tools, all of the libraries that the .NET team is building. Let me take a look here at some of the comments in the chat room and catch up here. There's a couple of good questions. I want to make sure. Let me answer this first question from Palaman. Will .NET Core eventually replace .NET Framework or .NET Standard? I've purposely avoided talking about .NET Standard as much as I could here on these streams, but there are 4 .NETs that are out there: .NET Core, .NET Framework, .NET Standard, and .NET Xamarin. .NET Xamarin is that user application framework and tool set used to build for iPhone and Android, and a number of other targets, but primarily you'll see folks use it for iPhone and Android. .NET Framework is a framework that was originally shipped in 2001 that helps you build websites, console applications, class libraries, desktop applications for Windows. It ships as part of the Windows operating system. You will, as long as there's a version of Windows, because so much of Windows and the tools and features inside the Windows operating system rely on .NET Framework for how they're maintained. You will always see .NET Framework being shipped with Windows. It's never going away. .NET Core was a new version of .NET that was built and released. They started building it in 2014. Was first released, I believe it was 2016, and is intended to be a smaller, lighter, and faster version of .NET, completely rewritten, has a lot of the same features as .NET Framework, but was intended to be built and used for the cloud. Originally was intended to be built and used for the cloud. It's evolved, it's brought in some of the features from .NET Framework you saw already. Windows, and I think it's here somewhere, Windows Forms applications, WPF applications as well, and has ASP.NET in there, so you can build projects appropriately for the web, for the cloud, and it also has the cool new Blazor framework that you can use. You can build for gRPC, you can build APIs, all kinds of great stuff that you can build with .NET Core. The next version of .NET Core is what we're calling .NET 5, and it brings in the last of the features from .NET Framework that are intended to be used going forward as the light and fast framework that you can install quickly and easily, not just on the cloud, but also on Windows, Linux, and Mac environments. .NET Core supports Windows, Mac, and Linux amazingly. Very, very well. Top line support you have for all three of those. There isn't one operating system that's treated better than another. In fact, .NET Core was specifically shipped outside of Windows so that we don't have to wait for Update Tuesday in order to update the framework. If you need to update and we need to ship a patch for it, we can ship those patches immediately. You can apply them and you'll have great support for those frameworks. So there is great love for all the operating systems from .NET Core and the next evolution of it that's being referred to as just .NET 5. The next question that we have here in the chat room is from Antidotos. Antidotos? Anti.os? I'm not sure. Do I feel like in a Linux platform when using command with .NET Core as a Microsoft tech developer? No, I don't. I feel like I'm on the command line. I'm used to being on the command line because as a more mature developer, I've been around and writing code for Windows and DOS operating systems before that, since the 90s. So working in a command prompt, a command shell, is something that I've always been accustomed to. I very much appreciate that the command line is the one unifying point that all operating systems have. Whether it's Windows, Mac, or Linux, you have a shell that you can drop into, use that command line to build and work with whatever it is that you might want. So the commands that I'm going to be executing here, like .NET New, work just fine whatever your operating system is. So as a Microsoft tech developer, I'm okay using any of those three operating systems. On my stream here on Twitch, twitch.tv/CSharpFritz, we spent the last month working exclusively in Ubuntu. In March, on that same channel, we spent a few weeks working exclusively on a Chromebook inside of Chrome OS with .NET. All the tools to make you productive, and they work everywhere. Really, really great stuff. No, Lithics, I am not a senior developer. I've aged like a fine wine. I'm mature. I've gained wisdom, knowledge, and I'm passing that on to you. Yeah. Jeremy Knight has a question here, and then I'll get back into our project. Does .NET 5 have an answer for cross-platform graphical user interface? WPF, Windows Forms, anything like that? It does not. This is where the version part of the .NET 5 effort that was postponed to .NET 6. It was dropped. Year 2020. Software developers haven't postponed or dropped any features and delayed any things that they've been trying to accomplish. Yeah, I'm looking at you, CDPR and Cyberpunk 2077. Delayed again. They delayed this feature. The .NET team delayed this feature that was initially called .NET MAUI, that was intended to be a multi-platform user interface library that would work on Windows, Mac, and mobile environments out of the box, and provide support so that Linux community members could help integrate their favorite UI stack with MAUI and be able, with .NET MAUI, and be able to make that work on your favorite Linux distribution. But the scope, the size of that effort and pandemic caused a decision to be made to delay it for .NET 6. So, no, they did not delay .NET MAUI to clash with Cyberpunk 2077. No. That's a fine question, Mufana Blue. I don't mind answering this, and I'll get back into the code. So what's the point of installing and using .NET 5 since it's not released as an LTS version? If .NET 6 is the next LTS, wouldn't it be better to wait for .NET 6? This is a good question, and this brings up in this support cycle, there are two different, and you see this in other open source frameworks. There's the difference between the current version and the LTS version, the long-term support version. .NET Core 3.1 is an LTS, a long-term support version that you will have 3 years plus 1 year to convert, to migrate to the next version. You'll have 3 years support. A current version, like .NET 5 and .NET Core 3.0 before that, were current versions that you had 3 months to upgrade to the next current version that is released. Now, why would you choose to install and use a current version instead of waiting for an LTS? It's really a question of a trade-off: long-term support versus improved performance, tools, and techniques that you may need access to. If you want to build with the new latest and greatest, there's a gRPC API in here that is the fastest running gRPC server and client that you can get anywhere on the web, and you can learn more about that on the .NET blog. But if you need that performance, you may want to upgrade and build with .NET 5. If you need support, well, okay, stay on .NET Core 3.1. There's nothing wrong with that. It continues to be supported, and wait for .NET 6. This is about choices. This is about flexibility. There's folks who do like to be on the latest cutting edge versions of things as they prototype and build, because when we go from .NET 5 to .NET 6, there won't be as much of a change as going from .NET Core 3.1 to .NET 6. So you trade off migration needs and techniques with advanced tooling, support, and these are choices that we all have to make. Certainly if you're building a system that you need to support for the next 10 years, absolutely stay with .NET Core in that long-term servicing release. Wait for the next one. And since we know that .NET releases going forward will be released in November of each year, there is a .NET version that should be released. Since we know November 2021 is when .NET 6 is going to be released, you could plan, okay, well, I'll do my team's update from .NET Core 3.1 to .NET 6 for January 2022. Take a month to experiment and make sure that evaluate that this is exactly what I want to do, and do that patch update in January 2022. You have that flexibility, and now you have that knowledge that you can use to schedule appropriately. So, all right. And .NET 6, that should, Lithix points out, .NET 6, that should come out about the same time as Cyberpunk 2077. No. We kid. For those of you who don't follow the reference here, Cyberpunk 2077 is a game that was originally announced in 2013. It won Game of the Year for, I forget which show it was in 2013, 2014. The marketing folks were working hard on this game. Previews were and playable demos were released in 2018. It won Game of the Year at E3 in 2018. They were revised and a release schedule was published. It was supposed to come out in 2019. It won Game of the Year at E3 in 2019. They had to delay it into 2020 because they weren't quite ready for it. It won Game of the Year again at E3 in 2020. It won Game of the Year after it was delayed because pandemic to later in the summer. It won Game of the Year from Twitch for 2020. It was delayed again to the fall because they weren't quite ready yet, and now you can buy all the custom Xbox and controllers and Funko, all the cool stuff that comes with the game that you would expect. And it was delayed again to December 2020 because they're not quite ready yet. We'll see. More coming soon. So it's interesting. It's won Game of the Year 3 years running and still hasn't been released. So this is a problem that many of us as software developers have around managing scope, managing expectations, communicating with our marketing team so that they let our customers know when new versions and new features are going to be released. So you make choices like the .NET team did to cut .NET MAUI from .NET 5 and move it forward to .NET 6 because we have a scheduled release date, scheduled time frame when that's going to come out. All right, let's get back into our project. These are all the templates that we have. Let's start building a class library, right? That's the typical, no, you know what? Here in the demo, I think I actually talk about building a console application so we can build and actually run an application to start. And we can build our first application by saying .NET new. We specify the name of our template, and I use the short name here so that you can reference and build that. I'm going to build a console application that runs right here on the command line. I can choose which language to write things in. By default, you see in brackets, C# is the language that we use to build these. So I'm going to build a new console application, and I'm going to pass in the O switch here to tell it, well, write it out to a folder, and I'll call it App1. Now, this command is actually going to run two different tasks. Not only is it going to create a copy from the template of the console application, but it also is going to restore any references. There's packages that are referenced inside of that template that we need to copy and make available on our machine. Now, if you've been running projects, if you've been building projects for a while on your machine, it won't have to download them. It keeps a copy in a central location, and all that restore process does is just creates a pointer to where the version of that package is on your machine, so you don't have to waste drive space. Nobody likes when frameworks and tools waste space on your hard drive. So there we go. All right, so it created, and in 97 milliseconds it restored, and I can now go into that app folder. I can take a look, and I have an obj folder. That's where the information about where those packages were found is written into the obj folder there. For us as humans, you don't have to go into the obj folder 99% of the time. There are times you're going to want to peek in there. You can go ahead and take a look in there, but it's not a folder that we should maintain by hand. Let the tools maintain that. That's intended to be a machine-maintained folder. But there's two other files here, app1 csproj and program cs. If I take a look at program cs, you see C# code. We're used to seeing C# code. Here it is, our first program, and it has a static void main method, right? We've seen methods before, and it says console writeline hello world. Easy. I can run this application now with the command .NET run. Now, .NET run actually does three things for us. First, it outputs hello world. That's first, it will look to make sure that the packages are restored properly. And right, there's stamps and hash codes that are passed around, so it determines very quickly that it doesn't need to restore. Second, it compiles the application, right? And compile is something that we haven't discussed yet, right? For those of you that aren't used to using a compiler, real easy to understand. The C# compiler that is triggered by the .NET command line here will wake up, take a look at this text that we wrote, the C# text, and turn that into executable content that we can work with. Finally, it will actually run that executable content, and we get the console write line. It wrote out hello world. Easy. Real easy to understand those few steps that it did. Now, where did it write that out? If I look at my folder now, you see I have a bin folder that I can go down into. If I go down into bin, you see there's a debug, right? So if I go into there, there's now a folder called net5. This is the .NET 5 version of the project. And if I take a look there, there's my executable, app1.exe. There's a bunch of other files here that have information about how the project was structured, what it was, how we can go in and debug it if we have a tool that has a debugger like Visual Studio or Visual Studio Code. you can use a debugger, and these files will be used by that tool to allow you to interact with your code and step through things, set breakpoints so you can work with it. So, not bad. Okay, I can understand this. And I should be able to run app1 directly here. No, right now I'm going to, there we go. I'm running in PowerShell here, so it's confusing me. But there we go. Hello world, and it outputs quickly. No big deal. Nothing groundbreaking here. But what I do want to show you, let me go back up. There was this project file also, right? This CSproj. Now, if you're used to Python, you don't really have a project file. Or maybe you're used to TypeScript or JavaScript, working with Node, and you have your package.json file that has references to all the packages, has some information about how you can be turned into, your project can be turned into a Node package. Well, how do you, right? You have that manifest file that defines those things. So this is something that we can dig into and take a look at. And you'll see it's got a very simple format here. It's XML so that it maintains compatibility with all of the .NET projects going back all the way to 2001, back when we believed XML was a good format for storing and presenting data. You'll see there's an SDK here. This SDK attribute on the project says we're using the .NET SDK, the generic .NET SDK. There's more specific ones that we can use for different frameworks, and you'll see that a little bit later. We specify a property group that says, well, we're going to output an executable file, and we're outputting that for the target framework, .NET 5. Now, there's other things that will appear in these project files as we add references to other packages, to other projects, and we can also include information in here about how we handle the various files inside of our project. By default, files that end with a .cs extension, those are C# files. Those files will be compiled and included in the binary output of the compilation process. Let me take a look over here at the chat room and see if there's any questions that I want to take a look at here, catch up with. Hey Shane, good to see you. Priyank has a question here. That's a good point. I kind of skipped over that. Let me touch on that question that you have there. Very good point. Priyank has a question here. Is there a command to only compile and not run like the Java compiler does? Absolutely, you're right. I kind of jumped through that quickly. I can execute. I mentioned when I executed the .NET run command, it restored packages, built, and then ran the executable at that point. You can run those separately. They're separate commands. I can execute .NET restore to restore packages and references. I can run specifically to compile and not build. I can run the .NET build command, and it will build and tell me if there's any warnings or errors at that time. It'll also tell me I'm using a preview version of .NET so that I know it's a preview version. I'm going to need to update at some point. Finally, I can .NET run, and it will go through, do those 3 steps, and run my application. You can pass some switches into these. If you pass -- help, it'll show you all the configuration options for whatever verb you want to execute with .NET, right? If I just execute .NET, it'll show you the basic switches here, and you're hiding behind Priyank's question. Right? But .NET help, and you can see here's the base verbs, the commands that you can execute from .NET. There's other commands that will be added as you install additional tools, because just like our templates, the .NET command line is extensible. You can add features to it. So if I take a look at .NET Run, because I've already built, because I've already restored, I can actually say .NET Run no build. And it will run it immediately and not even attempt to restore packages or build the project. It just runs the last version that it has built. That might be important to you. That might be something you want to do in your continuous integration processes. So at the command line, that's how you would do this. I see some folks in chat talking about working within the various development tools, development environments, whether it's I see Visual Studio 2019. I see some folks talking about Visual Studio Code. Very cool. Yeah, I'm not going to get into those specific tools. I'm going to stay as simple as possible here. And we'll get into using Visual Studio 2019 in the near future. So, all right. So I have App 1. I built my first application. There's all kinds of options and tools that you can put into that configuration file, that CSproj file. There's a link in the documentation in the README for today's session if you want to learn more about all the configuration options in a project file. For the most part, what I want you to understand is you don't need to touch that project file by hand. You can pretty much work with that using just the .NET command line tool. So let's start building our first project with some code that we can actually start testing. And we'll call this project Logic. That'll be part of a simple shopping cart application, and we'll build up to this very quickly. So let's make a new folder here, and let's call this shopping cart. Okay. There we go. Jeff can't type. So let's create our first class library, and let's just put our business logic in this. This is our shared business logic. It's a class library. It's going to restore, place all the content inside of a folder here called logic. And it by default has this first class 1 CS, right? And a class library is a reusable unit. It's a non-executable unit. You can't build a standalone application from a class library. This is a unit of binary code that you're able to reference from various projects, various user interface frameworks, whether it's a web application, a mobile application, desktop application, application that runs on WebAssembly. You can use class libraries across any of those different frameworks. Let's take a look at what that project file looks like. Now, remember earlier, I already cleared the screen, you can't see it. Remember, we had an exe entry that was dropped in here that told us that the output type was an executable. Well, we're not outputting an executable here, so that output type exe isn't present. We're still outputting for .NET 5, and we're using the .NET SDK to build this bundle of objects and things that we're going to reference going forward. So I'm going to use Visual Studio Code to work inside this folder. I'm just going to copy that and open Visual Studio Code here. A lot of folks like Visual Studio Code. It's currently the most popular text editor developer tool on the planet. So that's pretty cool. We can use that. So I'll open folder here and we'll start working on our shopping cart. So I have my logic folder and I'll open that class file, and here is the basics of that class file. And I love that they use space indenting here. For those of you who may not have seen some of my other streams, my other videos, I'm not a fan of space indenting. It's not accessible to folks who have vision problems. So it's something that is important to me, that we encourage folks who who might not be able to see your code to be able to read and understand that appropriately. So let's define what a product is that we're going to work with here. I'm going to control dot. And, oh, you're not going to let me do this. It's not there. That's fine. Over here, product. And I should have, let me make sure. I'm going to restart Karnak. I have an indicator that'll run up here in the corner and show you exactly what hotkeys I'm running. There it is. Control S to save. So as I'm using Visual Studio Code, you can see the hotkeys and maybe learn how to better use Visual Studio Code from seeing some of the things that I use. See that? Look at that. It's using spaces anyway. You make me sad. So I'm going to define. Yep, you're going to be a pain in the neck here, aren't you? And not give me. There we go. There's snippets that you can use with Visual Studio Code when you're building. Now I'm getting tabs. When you're building properties, you can type prop, and it will give you an automatically implemented property here. So I'm going to implement a product ID. Come on now, there it is. We want a name, right? And let's provide a decimal price for our product. Simple, it's a product, there we go. And it just works. I'm going to open a terminal here inside of Visual Studio Code. I'm going to drop into that logic folder and let's actually build our project, right? I can work right here inside the integrated terminal and .NET build. It's not much. I just put a class in here and it builds successfully. No warnings, no errors, and away we go. Good. That works great. Jeremy has a question here in the chat room regarding .NET 5. What's the story for sharing code to .NET 3.x projects, older versions of .NET? Is it just using .NET Standard? Yes, you can use .NET Standard 2.0 and 2.1 to build projects that are capable of being referenced by older versions of .NET, whether it's .NET Framework, Xamarin, or .NET Core. Going forward, we're going to have everything in one .NET. There will be just .NET 5, just .NET 6, as Xamarin gets folded in and becomes .NET MAUI. And we have one user interface framework that we can use to target all the different devices, different operating systems. So if you want to target the older projects, yes, use .NET Standard. So, and like I said, I'm purposely trying to minimize some of those complications by focusing on .NET 5 today. So, great. I've defined a product, I can build it, and now I have this object. Big deal, right? We also have something here that I need to call out that we haven't seen in our notebooks. We have these things called namespaces. And a namespace is just a logical unit of organization for your code that you can use to navigate and reference and get around the various projects. And the various binaries that your project may be referencing. So that's important to be able to have that level of organization. Now, in .NET projects, I don't know what that was. In .NET projects, we typically create a root level namespace that has the same name as the project. Logic. If I were to create a child folder that had the various accounting business logic in it, right? If I were to make the accounting folder here and go into that folder and, right, so there's my folder here. If I were to create a new file in there and write whatever, some file, by default, The namespace that we would expect to have in here would be logic.accounting. This way we have, when we're writing our project, when we're writing our code, we have the same logical groupings on disk that we do in our code, right? You effectively, by looking at the Explorer pane over here on the left, you effectively have the same organization for your classes, interfaces, enums, the various objects that make up your project. You effectively have the same organization for those as you do inside of the .NET memory space. I hope that makes a little bit of sense. How's it going, Chris? Good to see you. So, but I'm not going to use test.cs. I'm not going to put anything in here. But this is what it would look like, and I would then be able to reference objects from inside of that test.cs, right? Let's create a class here. Public class test. I'm not going to put anything into it, but if I created a method here, public void, not food, foo, var t equals new test. Well, wait a sec. Right, I can't find test. It's not in my list of things that it's suggesting. And if I force that, right, I get a little red squiggly here because it doesn't know what that is and can't find it. Can't find it because it's only looking in the logic namespace. It's not looking down into the accounting namespace, right? And that red squiggly line, that red underline, right, is being delivered to us because there's a compiler behind the scenes. Are you kidding? I didn't save the file. There's a compiler behind the scenes that's inspecting and compiling our code, and it gives us an error. And yes, it's red text. Makes it easier for those of us who can see colors to be able to see that, hey, there's an error here. And it's clearly saying the typer namespace test could not be found. Well, how do we include a reference to that accounting space so we can reference test? Well, I mean, I could say new accounting.test and it'll find it, right? And I can go as far as to provide the entire, this is called the fully qualified name of that type, logic.accounting.test. I could do that. If I want to be able to say just new test and reference it like it was here right next to product, I can create a using statement up at the top here. And you see one using system, right? We never had to do this in notebooks because it automatically resolved these things for us. But we can say using logic.accounting, and it will now be able to find that test object and build properly. So that using statement is the same as what you might find in an import statement in other programming languages, where it's saying, here's a hint of another place that you can look in the object hierarchy that's currently referenced in order to go and find objects that are referenced inside this file only. Yes, that is a lot better than when you were using C back in the day and the only message you got was segfault and no idea where it is, right? Right? If I comment this out, the other bit of that error that I want to make sure that you can see here is it's clearly telling you on line 17, actually position 17 on line 17, there's that error. Let me bump that down a little bit so that you see that it tracks appropriately. Row line 19. So if I scroll down, line 19, position 17 is the test reference there. And inside Visual Studio Code, I can click that and it'll jump right to, I hold down Control, click that, and it jumps right to where it is, and I can read the error and address it appropriately. Now, there's all kinds of little tools inside Visual Studio Code. You'll see this inside the other developer tools as well, where I can hold down Control and hit dot, and it will generate using statements for me. if I roll that back, Control Dot, I can actually also have it provide the fully qualified name if I want to go that way. Your choice. Coding is a little bit of an art. Choose what makes you happy to build and write this code. So, great. I've got references to these things, and I mean, I don't really need this for what we're going to be doing today. I do need to end a little bit early, so I need to get on the move here so that we can start interacting. Now, this is one project, logic, but if I'm going to group together a series of projects to build an application, to build a larger system, I want to make sure that I put those in a unit. And we call that unit in .NET the solution. Now, solution is represented by a solution file that is written in a very old syntax that was used by much older Microsoft-built integrated development tools that you really, once again, shouldn't be maintaining by hand. We have tools as part of the .NET SDK to help you generate that solution file and manage the content of it. If you're in a full IDE, integrated development environment tool like Visual Studio 2019 or Visual Studio for Mac, there's visual menus that you can use to do that management. To do it at the command line, the simple way that you can do this, which is actually the same commands that those tools execute and interact with, is using the .NET new command again to build and interact with that solution file. And the solution file is typically at the root of the solution, and you have child projects that live in the folders underneath. So I only have the logic project folder here. I will add a solution file, an SLN file, .NET new SLN, and it will generate a solution file here for me. You see it appear over here. We can take a look at it, and it's not a format that you're going to recognize. It's like tab delimited with vertical pipes and properties with equals, and there's sections here that are tab indicated. It's not entirely clear what this is doing, but I need to add projects into my solution. So .NET SLN add a project to the solution, and I'll add the project that's in the logic folder. And you see my solution file changed. I've now got, look at this, now I've got all these other things down here in these GUIDs, right? These globally unique identifiers that are being referenced here, and there's a definition of what that project is. And it's got a pair of GUIDs that it's passing around. I don't want to have to memorize and reference and figure out what these things mean back and forth. That's a pain in the neck. Nobody wants to have to deal with that. Use the solution command line tools to interact with those. Not bad, okay? .NET SLN add logic. Let me add a couple more files into my logic project here. I'm going to grab them from the source code that I've already written. I'm just going to grab these three files, copy, and I should be able to just paste right in here. Here we go. So, just so you don't have to watch me typing, you know what I mean? Nobody likes to watch Fritz type. So I've added an order object. So an order has an order ID. It has a name of the customer we're going to ship to. It has a collection of order items, a coupon code, some coupon savings that were realized because of that coupon code, and a total cost of the order. Now those order items relate to an order ID. They have themselves an item ID, and they refer to a product. You put products into an order, and those products are line items. You have a number of products, a quantity of products that you're referencing on each line item, and a total price for that. Finally, I've also added a coupon evaluator that has our business logic apply coupon to an order, and if the coupon code on that order is save 10, well, we're gonna generate an entry in your coupon savings that says that the total cost times 10%. 10% of your total cost of your order are your coupon savings. That's a deal. That's a deal. Come shop at Fritz R Us and get your 10% off for the Save 10 coupon code. Anyways. So very simple set of objects here that we're working with. Let me get rid of this. I don't need this. Go away. Goodbye. All right. Right. Good. Product ID, name, and price. Good. So, I should be able to still build, and I can build all the projects in my solution by running .NET build in the same folder as the solution file. It'll go find all the projects and build them for me, and even though I've added these 3 new files, no warnings, no errors, everything builds properly. Great. But I think when you look at some of the things that we've dropped in here, we don't have all the logic yet. We still need to define some of this. And I'm not quite sure how we're going to manage coupon interactions going forward. That's something that I want to make sure doesn't break. Now, this is where we start to want to introduce tests and automated tests. For many years and still, there are a lot of folks that work in the quality assurance department. They do quality control. They review and make sure that applications work the way they're supposed to. But we as developers can also write tests that show, we can write automated tests, write code that exercises our code, and those tests can be executed to verify nothing broke from the way that the test intended for that code to be executed and evaluated. So you'll have various levels of tests, whether it's a full system test that somebody who works in quality control, quality assurance, runs and makes sure that everything in your system works properly, front to back, that somebody clicks on a button and it does a thing that makes something else happen, and they get an appropriate record that's delivered to them, or a shipping email that's sent to them that says, oh, they've properly ordered and this is the appropriate contents that we're going to ship to them. That's a full system test. There's integration tests where we're going to make sure that when you click a button on a user interface, it executes the business logic appropriately and an appropriate entry is delivered back to that user interface. That's an integration test. But the smallest test, the narrowest scope of test that we can help with as developers is called a unit test. And I grabbed a reference from Wikipedia. Let me open this up here. Yes, I know. I clicked on that so that you would open it. There's a definition for unit testing here in Wikipedia. Let me grab this for you and drop that link into chat. Unit test is a software testing method by which individual units of source code, sets of one or more program modules together with associated control data, usage procedures, and operating procedures are tested to determine whether they are fit for use. Plain and simple, we're going to execute a small individual unit of source code, in many cases a method inside of our classes, our objects, and make sure that that behaves the way we expect it to. We'll give it different inputs, we'll put that method into different scenarios, and make sure that it behaves the way we want it to. That's easy, that makes sense. Looking here at chat, catching up. Okay. Yes, Lithic's, very good point there. Let me bring up Lithic's point here. Because this is the value in unit tests. When they're compiled, they're saved and shared with your source code and will show that your application, that your source code is still doing what you intended it to do a long time after it's written, years and years down the line. So a unit test, I tell folks, is an investment. It's a little time investment that you make now that years down the line, you might not be with the project team anymore. But Skippy or whoever the developer is who comes along and is handling that project after you they can run your tests, and they know that the code that they're now maintaining still behaves the way that you intended it to run years and years ago, or whenever. I don't do time. Anyways, so it's a fantastic way to, folks will also refer to it as pinning functionality, right? There are some folks who are against the concept of unit tests because I'm writing code to test my code. Of course my code works. I wrote that code. Don't you trust me as a professional developer? It's not that I don't trust you. It's that I want to notify and provide a safety net, an insurance policy for the person who picks up and manages that code after you. I want that code to still behave the same way that you intended it to run. And by writing just a couple of lines of code to help assure that, you're now providing that guarantee. And when we look at modern development processes, DevOps processes, whether it's using a tool like Jenkins or Azure DevOps or GitHub Actions that will run your unit tests every time there's a change in your code, now we have the assurance that even before it reaches a customer, your tests pass. And there are test suites out there that have hundreds of thousands of tests, and they take minutes, hours to run. But if you have such a complex system and you can find out in minutes that you didn't break anything, in hours that you have such a complex system and you didn't break the way that something was intended to be run, that's a tremendous investment. That's a tremendous time savings that you don't have folks clicking and walking through processes to make sure that your code still works. So unit testing is a process, is a development technique that has become more and more appreciated and approved as a standard process in many organizations, and certainly in many open source projects where you're going to have folks contribute a little bit of code and walk away from the project. Well, I want a unit test to go with that contribution because you're not sticking around. You're not helping with the project going forward, and I want to make sure that it continues to behave the same way. So that's a little bit about unit testing. And unit testing is a practice that can be applied to any software language or framework. And here in .NET, we have several different tools, several different frameworks that we can use to facilitate building tests. And we actually saw them pop up in our .NET templates. So if I run .NET New again, you'll see these unit test frameworks pop up here. They are, where is it? I don't see, yeah, there it is. They are right here. We have a unit test project using MS Test. MS Test is a test framework that was built by Microsoft in the early 2000s that was intended to be used with Visual Studio so that you had a complete test experience. NUnit is a test framework, very simple test framework, that was built as a migration from the original Java-based unit test framework called JUnit. And XUnit is the evolution from NUnit version 2 to a more feature-filled test framework that was intended and designed to adhere to the way that .NET developers, C# developers, write and want to interact with their tests. So you have your choice. There's many other unit test frameworks. These are the primary ones that they come out of the box with the .NET SDK. And these are the primary ones that you'll see folks use. They all behave similarly. They all have very similar features in defining what tests are and the various test methods that you can interact with inside of your classes. So you can choose to use one of these. We're going to choose to use XUnit. Priyank, I see your question there. Let me pin that, and we'll talk about that in just a second. But let me add a test project and add it to our solution here. So I will create a new XUnit project. That's not how you spell XUnit. XUnit, and I'm going to write that out into the test folder here. So it's going to create it, restore, and place that file appropriately. I'm going to add that to my solution file so that we have that available. And I'm going to go down into the test folder. Let's take a look at what that test project file looks like. There's a lot more content here now. In fact, let me open that over in Visual Studio Code, because it'll be a little bit easier to see with the syntax highlighting here. Once again, .NET SDK, it's not producing an executable. Target framework is .NET 5. Is packable? Can we turn this into a package for reference? No, this is a test project. This is intended to be used with another library, right? This is a developer thing. And it adds these package references. So the Microsoft.NET Test SDK, how can we execute tests from this project? There's XUnit. There's an XUnit runner if we're running inside of Visual Studio that will be referenced, and there's information here about the various assets and things that will be referenced and used from that package. The last package here is called Coverlet Collector. These are the names of the NuGet packages that are being referenced. Coverlet Collector will help you collect and generate what are called code coverage metrics. How much of my code is actually being executed when my tests execute? Coverlet will help you review and identify those metrics. I'm not going to get into code coverage today. There's great documentation about that in the .NET docs, and there are links to those documentation articles inside the README for today. The question from Priyank here I want to bring up. How do you convince clients? How do you convince management folks that it's necessary and get budget allocated for unit tests? This is a problem that I ran into all throughout my career. Folks don't appreciate, well, you're going to write more code. You're going to write twice as much code so that I have tests that tell me that your code works. Why doesn't it just work the first time? Are you not confident in your code? This is a question about, like I said, creating that insurance policy, creating that capability to show that you're going to, in the long run, save money, because adding this little bit of investment of time now, it's not going to take you twice as long to write the code. It should take you about a quarter to a tenth of the time to test the code as it does to write the code. But it's going to help give that investment so that in the future, you're able to identify when things break immediately. And because let's face it, the cost of a bug getting into a customer's hands is significantly higher than the cost of adding a little unit test now that assures that it works properly forever into the future. That cost of a bug being identified, the reputation cost now that your customer found a bug, the cost of your quality assurance and operations team to identify and give you the log where that bug occurred, the cost then of your operations team or operations support engineers to go investigate and fix that bug, the cost of redeploying that fix, and the cost of now reclaiming that reputation that you lost because your customer found a bug. That's significant compared to the extra 2 minutes, 5 minutes that it's going to take you to write a unit test. That's a pretty good trade-off. So, Nix provided information and sold unit testing to Nix Manager as a means of providing to the client a number to help measure quality. Sure. The number of unit tests definitely helps indicate a quality level. However, the number of unit tests is relative to itself in time. By that I mean you might have 10 unit tests when you first have your minimum viable product. As you add more features, as you finish shaping the features to your minimum viable product, that number of tests may go to 15, 20, 30. Does that mean it's 3 times more, 3 times better quality because it's now 30 tests instead of 10? No. Does it mean you have 3 times as much functionality with the same amount of code coverage? No. It means that you've got 3 times as much code that's being tested and 3 times as much assurance that's being delivered. But if you're going from 0 assurance, that's a lot. If you're going from 10% assurance, okay, that's an improvement. But it's relative only to itself. You can't compare those 30 tests in your project to the hundreds of tests in somebody else's project. That doesn't mean that you've got so much less quality than the other project. It's only relative to itself. So, all right, let's move on. I don't have too much time left here. I need to get through and actually show you how to write a test. But if I want to write a test, right, I'm going to end up writing classes that look just like other classes that we've written in the past. And we add these attributes onto our methods. In this case, an attribute like fact. Now, this tells the XUnit test runner that this method is a fact that should be executed to ensure that it ran properly. We don't want to see any errors when test 1 is executed. So I can drop down into my test folder and I can run this test, not by .NET Run. .NET Run doesn't run the test. It'll build, but there's nothing to run, so it doesn't output anything. To run a test project's tests, you run another verb, test. So .NET Test in a test project does the same things that .NET Run did. Restores packages, builds, and then for that test framework calls into the test runner, points to the DLL, the class library that we built. There it is, test.dll. Points to that and says, hey, test runner, run any tests you find inside of here. Now, there's other attributes you can decorate your methods with besides fact. I'm going to focus on fact today. And when it finds those methods, it's going to execute those methods and make sure no errors are raised. And it gives a little report here. Passed. No tests failed. 1 test passed. No tests were skipped. And a total of 1 test method, there it was, test 1, was evaluated. It took 2 milliseconds to run that 1 test. Now, when you get into a bigger project and you can tell your boss, we knew in seconds that our project still works the same way, even though we added new features X, Y, and Z. That's fantastic. You know you didn't break those older features, right? Getting this little report is amazing. This is what you want. And when we're going through and writing these tests, right, I mean, we're not doing anything in this method. We need to actually start doing something with this. So let's write into here something to test. So there's a method called, there's an object called assert that comes with XUnit that we can use to test if things are equal, greater than, not null, should be null. I'm going to assert, and let's do something really easy here. Let's assert that 2 values are equal. Let's expect the value 2 and test the value 3, right? Or, right, maybe I've got some value that I retrieved from some other method, right? And let's call it the actual value. And let's say that's 3, and I can specify here actual value. So what assert does is it says, take this expected value 2, inspect the actual value being passed in from the actual value variable, and see if those are equal. If not, raise an error. I'll run .NET test, and you make me sad. Fine. Assert equal. Do that one more time. What? You're using a preview version? Yes, I know. Why didn't it? Why am I not? Assert equals is obsolete. This is an override. Use assert.equal. I didn't save the file. .NET test. There we go. So one total file, and there we go. Assert equal failure. Expected the value 2, but the value that was delivered was 3, and it shows me exactly what line that was where the test failed, and I get my little report here at the end. 1 test failed, 0 passed, 0 skipped, 1, and it took 5 milliseconds, right? And you can have many test methods here. Do the thing, right? And var x equals 1, and I can say assert equal 1 is x, and if I run that again, right, it'll come back and tell me 1 failed, test 1 failed, and the other test did pass. There were a total of 2 tests, and it ran in 28 milliseconds. So now we're seeing our tests, right? We start to add to them, and of course I can fix this. Well, actual value, I would go and fix whatever business logic was delivering that, and if I run that test again, it should come back and we should get all green. There we go, all green, 7 milliseconds, everything passed. Now, I know there is a little bit of an accessibility issue here. Red and green, right? For folks who might be colorblind, you're not going to see a difference in those, but of course it has the text at the beginning, failed and passed, to indicate that the test report failed. It failed if any number of tests failed. It passed if there are 0 failed tests. That makes sense. And you see, right, we've only got 2 tests here. It's right, very, very quick that it's executing these, and we immediately get that response. Yes, so some folks are getting into some of the other concepts around unit tests. So what if I wanted to run these tests whenever there's a change? Right? Whenever there's a change to these files, go and rerun the tests. Well, there's a command that comes with the .NET command line called watch. And I can pass another verb after that I want it to rerun should any of the files in this project change, or any of the projects that this project references change. Go and redo. So I'm going to execute .NET watch test. You see it starts watching. It's going to go and execute all my tests. And now it's waiting for a file to change before it goes and reruns the tests again. So if I went and changed some of my code in whatever other project, and the actual value now is 3, and I saved that file, I just saved the file, I didn't re-execute anything down here, it automatically went, reran my tests, and in 7 milliseconds, I haven't even left this file yet, I'm still working, and it's automatically telling me, you broke the tests. So hopefully getting that immediate feedback for us as developers will help to get you to go back, oh shoot, I went and changed that thing in that place, and hopefully it fixes that back to whatever value, and now I know my tests work again. There are plugins you can get for all the various tools out there. Visual Studio Code has a bunch of plugins. Visual Studio 2019 has plugins that you can use that will automatically run tests for you as you change files, as you build projects. Visual Studio for Mac has them as well. There's all kinds of great tools out there for this. I have a little plugin here. This is the .NET Test Explorer, and I can tell this exactly where to go to find my project. So test project path, and go find it in the test file. This will go and discover tests, and it'll come back and show, there it is, there's my tests, and I can click this and it will run it. And I'll know immediately, and I'll see here in the panel that my tests work. So if I'm over here working, right, I don't need to have this watch running here in the background, right? I can just be doing whatever thing over here, make my change, and I can execute the commands to run this, Alt-R, Alt-A, right? Well, let's make sure that my tests run, and you can see they're all executing, and I know immediately, oh, I broke test 1. And the plugin automatically highlights, well, there's the line that threw the error. And it shows me with a little peek window there exactly what the error message was, and I get a little indicator that shows which tests passed and which ones did not. And it'll go rerun the tests, and I'll see. A couple questions here. Let me bring these up. There's all kinds of tools that will help you with this. But Vivala Manuel asks, will it only rerun tests that have to do with the files you changed? If it's in a project that you referenced, it'll rerun everything. If it's in a test that you changed, it actually, when you do .NET Watch, it reruns everything. You can use smarter tools that are available that will appropriately find exactly those lines of code and things that are referenced that are impact that will only test those things that changed. There's things like live unit testing inside of Visual Studio. I see somebody else here. John Calloway mentions NCrunch is another tool that does this level of analysis and will give you exactly those lines of code that are broken and only execute those tests that are impacted and give you a much quicker experience at evaluating the impact of your tests, the impact of your code changes. Some people like that, some people don't. But there's all kinds of tools out there that you can use that will help with that. And I'm just showing you a couple of simple ones. I'm here in Visual Studio Code, .NET Test Explorer, and .NET Watch Test. You can run that. I like to have tmux running on Linux, and I'll have inside of a lower panel my .NET Watch Test running that shows me whether I broke my tests, and in my top panel I'll have Vim running, and I'll be writing my code up there, making changes, and when I save files from Vim, I'll immediately see that my tests ran and executed properly. The test extension that I'm running over here is .NET Test Explorer. Right, Test Explorer. You're not going to show it to me, are you? There, .NET Core Test Explorer. This is the one that I'm using. So, easy to use, and helped out right there. Yes, our friend Scott Hanselman has a blog post about generating markup here in Visual Studio Code that'll give you information about what lines were actually executed, tests that passed and failed inside your code. I am just about out of time, and I'm way back here. I haven't gotten through most of the code that I wanted to today. We had a lot of good conversations. I do want to show you how to add references to other projects. So we're inside of our test project. Let me go over to the console. We're inside of my test project, and I want to test code that's over in the logic project. Well, you do that with the .NET add command. And the .NET add command will let you add references to NuGet packages. Those are available at nuget.org. Or you can add references to other projects that are on disk. So I'm going to add a reference to the logic project from the test project. So now if I take a look at that test project, right, we had these package references here to all of my test framework things, but now it adds an item group, and there's my project reference, so that it knows to use the logic project as part of the test project. This means if I go back over to Visual Studio Code, inside my unit test 1 here, right? Let me run .NET Launch Test here. If I add, let's add another fact, public void, and let's say, right, we're going to take a look at the coupon evaluator. Should give, it's what was it called? Save 10. When save 10 code is used, should grant 10% savings. Notice the name of my test here. The thing that I'm testing, coupon evaluator, I have a when here. When the save 10 code is used, should grant 10% savings. I'm very clearly defining the narrow scope of the coupon evaluator that I'm going to be working with. And I like to typically use a 3A pattern here. Arrange, act, and assert. Now I save that and it's going to tell me that test passed. Right? Say 3 tests passed. But I haven't actually written any code in here yet. So arrange, I'm going to set up the things I need to test that that 10% code. So let's create a new order. And let's put in that order, well, the coupon code, right? It is coupon code. There it is. Right, save 10, and that runs off of the total cost, right? So I'll say total cost equals, let's make it really simple, equals 100, right? Act. So let me create my coupon evaluator, and I'll just call that coupon evaluator. New coupon evaluator. Good. And I want to evaluate. I want to actually run it against my my order here. Let me reload the window so that things get set up properly here for me. Thank you. Down here. Okay. And this is going to come back and tell me, hopefully, very quickly. Oh, it doesn't know what coupon evaluator is. Right. Because that's in a different namespace, right? So there we go. I get a red squiggle. I'm going to control dot. I need to bring in my using statement for the logic project. So I save that. It's going to go and restore. It updated and built both projects. I'm still passing. I haven't written any code to actually evaluate anything. But let's act. Let's actually act on applying our coupon, right? That's this method here. I'm going to apply the coupon to our order, and I should get a coupon savings that is 10% of that. So I'm going to pass in that order, and I know that 10% of 100 is 10, right? So I will assert dot equal, I'm expecting it to be the value 10. And it should be, right, coupon savings is a decimal. I'm going to take a look then at the coupon savings and see if that matches. So it's going to run that. And I should know immediately if my coupon evaluator works. It does. I can make sure that, right, that it's calculating it correctly. Well, is it equal if I say it's $1 that it was saving? No, it breaks. And I immediately know, I expected it to be $1, but it actually delivered $10 US dollars. I'm in the States. So I can properly update that, save it, let it rerun, and I know my test ran properly. Fantastic. So, real easy to see. And now I also have, check this out. So I have, because, right, I have tests now in the project, I can actually click and run just these tests if I'd like right here directly. And it will tell me just that one test if it ran. Or I can debug through and actually see what it's doing in Visual Studio Code by clicking debug test with a breakpoint here, and it will stop when it hits that line. And I'll be able to see exactly what's going on inside my code, right? It's going through, loading up, there we are. I'm stopped at this line. There's my order object. I can open that up and I can see there's the total cost, there's the coupon code, and I can let that run through, right? All kinds of great things you can do with your tools. And let's make sure that, right, let's add another test here that says when save 10 is when, let's say when no code is used, should not grant savings, right? So no coupon code, apply the coupon savings should be 0. I'm going to save that and let it rerun. My .NET watch is still running over here, and now I have 4 tests that run in 8 milliseconds. I know that it's properly letting it go through. Fantastic. This is what you want to see when you write and run unit tests. Quick feedback. Very simple to write, to set up the scenarios and know exactly that you didn't break anything, right? Because let's face it, when you're in that coupon evaluator, if you're over here and right, somebody does some refactoring and changes that, well, if I didn't have that 4th test, right, I wouldn't know. And I see you there, Dee Dee. Thank you so much. I'm breaking here in just a minute. I know immediately that I broke that one test, that it's now always granting savings. That's a problem, right? If I didn't have this, right? So that brings up a good point, that not only should you test the positive of something working, test the negative also. Test to make sure that it does properly handle an error scenario, right? Handle when something shouldn't work. All right. Put that guardrail back in, and I should be back to 4 tests running. Fantastic. That's all the time that I have today. I am out of time. Let me stop the music over here. I really appreciate you joining me. It's there's so much to learn. There's so much that you can go into with unit tests to make your projects better. And I hope you spend some time. There's going to be a lot more content available around practices inside that README. If you're reading it now, you'll see the notes and things that I had in there. I'll finish filling that out, and it'll be uploaded with the YouTube recording a little bit later today, probably this evening, because I've got a full day of interviews that I'm going to be conducting for .NET Conf. Friends, if you're watching us here on YouTube, I really appreciate you watching. I hope you check out the rest of the Fritz and Friends, the C# with CSharpFritz video series here, and I will see you next Monday, where we'll be talking about working with database. Take care.